Every web Dynpro controller has exactly one hierarchical data storage structure known as the context. The data held in the context exists only for the lifespan of the controller. Once the controller instance has been terminated, all data held within its context is lost. The structure, that is, the metadata of the context, is typically defined at design time. However, at runtime, you can modify the contents of the context and can also dynamically modify the structure.
The figure shows the different steps of changing the context nodes and attributes using different options in the application screens.
Unless declared differently, all runtime data in a controller's context is private to that component. You can make the information held in the context of the component controller or of a custom controller easily accessible to the context of another controller, like view or custom, by a technique known as context mapping. Using this technique, two or more controllers can access the same runtime data. Context mapping is the primary mechanism for sharing data between controllers within a single component. Note, it is not possible for a view controller to share its context data.
All controller contexts are constructed from a hierarchical arrangement of entities known as nodes and attributes. A context always has a parent node known as the context root node. This context root node has fixed properties and it cannot be deleted. All the child entities of a node are aggregated into a unit known as an element. A node can be thought of as a collection of such elements in the same way that a table is a collection of rows. The name of a context node must be unique within the complete structure of a controller's context. A context attribute is an entity within the context that is not permitted to have children. A context attribute cannot exist without being the child of some parent node, be it the context root node itself or some other node.
The figure shows the node object creation at runtime and the context root at design time. At runtime, a node object and a node element are created for the context root automatically. The reference to the node element is stored in the node's attribute collection.
A structure is generated at runtime for the context attributes related to the context root. The reference to this structure is stored in the attribute static attributes of the element. A node object is created automatically for each subnode of the context root. The references are stored in the attribute child nodes of the context root element.
Many node properties set at design time govern memory allocation. For example, the dimension of data array to be stored at runtime. It is therefore essential to understand the properties of nodes. At design time, you create the metadata structure within which the runtime data is stored. All context nodes are collections, so there could potentially be multiple element references stored by a context node at runtime. Every context node has a property known as cardinality. Cardinality describes the maximum and minimum number of elements that the node collection may hold at runtime. All nodes contain an element collection, even if the maximum number of elements within the collection is limited to 1.
A node cannot exist if the collection of the parent node object is empty. That is, elements related to the parent node do not exist. This means that the existence of nodes that are not defined as direct children of the context root node or dependent nodes is not guaranteed.
The figure shows that the structure of the context at runtime is not the flat, two-dimensional hierarchy which is at design time. At runtime, the context consists of multiple dependent objects. This can be compared to an internal table in ABAP at design time and runtime. At design time, the metadata of the internal table comprises the structure given by the line time. The dimension of the internal table, that is, how many lines the data object holds at runtime, is not part of the definition. At runtime, multiple lines can be appended to the internal table data object, just as multiple elements can be appended to a collection originating from a context node at runtime. However, because there are no restrictions on the minimum and maximum number of lines an internal table can hold, there is no counterpart for the cardinality property. Internal tables always have 0 lines after the declaration of the object, and they can hold an unrestricted number of lines at runtime.
Each context node contains the attribute lead selection index. This attribute of type integer is used to simplify the access to the node's collection. The lead selection index is set automatically by the Web Dynpro framework if the context node property initialize lead selection is set to true. In this case, the attribute is automatically set to 1 as soon as the first element has been created. The lead selection index can also be set by program source code, or it can be set by user actions related to UI elements, for example, by selecting a line in table UI element bound to the node. Hint: the lead selection index is cleared by assigning the value of the constant if WD context node implies no selection.
In the controller source code, special methods can be used to access the value of a node's lead selection index and the element related to it. Lead selection index is important in the following situations.
The figure shows that the context node N1 has a child node called N2. The N2 node is a distinct node with its own element collection. The Boolean property, singleton, critically affects the relationship between a node and its parent node. If the singleton property of the N2 node is set to false, that is, node N2 at runtime is a non-singleton, which is the default, then for every element in the parent node collection N1, there is a distinct instance of the child node N2. The most important thing to understand here is that each instance of the N2 node is related to the respective element in the parent node collection. Note that the arrows pointing to each of the N2 node collections originate in the elements of the parent node. Therefore, if there are n elements in the parent node, there are n distinct instances of a non-singleton child node.
If the singleton property of the node N2 is set to true, the number of elements present in the parent node collection N1 does not matter. There will only ever be one instance of the child node N2 for the N2 at runtime if it is a singleton.
The figure shows that there can be many different elements in the N1 node collection. We need to ensure that when the child node N2 is accessed, it contains the correct data for the selected element in the parent node. Supply functions can be used to ensure child nodes are repopulated automatically. a supply function can be assigned to each context node of a controller. This supply function is automatically called by the web Dynpro runtime under the following conditions. If the collection of node is initial, if the lead selection index of the parent node is changed, if the collection of the node is invalidated programmatically. Hint: for all of these situations, the supply function is only called when necessary. If the child node N2 is neither accessed programmatically nor bound to any UI element on the next view assembly, the supply function is not called. Supply functions may not be called from the source code of a controller method. Only the web Dynpro runtime can access such a method.
A supply function can be assigned to a node by setting the value of property supply function. As a result, an additional controller method is generated with a given signature. A reference to the element at lead selection in the parent node with name parent element allows access to the attributes of this element. A reference to the node to which the supply function is related with name node allows you to store the dependent data in the child node's collection.
Web Dynpro follows the principle of lazy data instantiation. The data is only created when it is actually needed. When this principle is applied to the context architecture, the child node remains unprocessed unless the program actually needs to look at the data in it. Context mapping allows a controller, typically a view controller, to access data that was pre-processed by some other controller. Since a mapping relationship allows a direct reference to be made to data in another controller, there is no need for this data to be copied or moved. The context node that acts as the data source is known as the mapping origin node, and the context node that is mapped is known as the mapped node. Note: a mapped node ceases to maintain its own element collection. Instead, it references the element collection of the mapping origin node. A view controller cannot act as a data source for a mapping relationship because this would violate the principles of MVC program design.
Once the data has been generated, the component controller or custom controller then supplies it to a view controller for display. If a view controller acts as the data source or origin for a mapping relationship, a situation can arise in which the component controller or custom controller is dependent upon functionality found in a view controller. This is a bad design and is therefore not permitted. To establish context mapping between two controllers, the target controller has to declare the source controller as a used controller in its properties. If the context tab page is chosen in edit mode of the target controller, the contexts of all used controllers are displayed on the right side. Hint: if the node you want to map contains attributes that are not contained in mapping origin, then these attributes are deleted when mapping the node. Hint: mapping origin and mapped node may have different names. After executing the mapping between the two nodes, all of their elements are mapped, including attributes and child nodes. If the node structure of the mapping origin changes, that is, elements added, deleted, or modified, the mapping can be updated or synchronized using the context menu of the mapped node.
Internal mapping is the name given to a mapping relationship in which both the mapped node and the mapping origin node lie within the boundaries of one component. This means that the mapping relationship can be fully established when writing the current component. However, there is a special case in which a mapping relationship can only be partially established when writing the current component. This is known as external mapping. This is a situation in which the mapping origin node lies outside the boundaries of, or is external to, the current component. External mapping in detail is covered later in the course.